Today we're going to talk about one of the more challenging aspects when you first learn coding, and that's recursion. I've got to be honest, it took me quite a long time to figure this out, and it's because it's so very different to for loops and while loops and any other form of iteration. Now, I was on Reddit a while back and they did have this really nice, clean explanation. And so they talked about it as this idea of a cinema. Now, let's assume these people are following the rules of computer. It's a little bit unrealistic in some ways, but perhaps it's a very dark room. You really can't see the person in front, so you've got no clue where that first row is. So the person back here says, which row am I? Well, you're not row 1. And so they then ask, which row am I? Well, not row 1. And they go and ask, which row am I? And then the person in row 1 says, row 1. And he goes back. Okay, I know I'm row 1 plus 1, row 2, row 3, row 4. And so you understand what is going on and how it works. Now that's a very simple example of exactly how recursion works. Now before we get into this, I want to stress there are a couple of things you absolutely need to know before you engage with this video. Number one, you need to know how if statements work. So you definitely need to know that. And number two, you need to be very confident with functions. So let's be very clear with that. You need to understand how functions work and how they return things before we start this. Otherwise, it's going to get very confusing. So this is a factorial formula. Hopefully one of these formats works for you. 1, 2 times 1, 3 times 2 times 1, 4 times 3 times 2 times 1, 5 times 4 times 3 times 2 times 1. And that's all you need to know really, is just this idea of the two numbers before get times to create your thing. And so for 5, that'd be 120. Pause the video here if you're not quite sure on a factorial. It's a nice clean example and most of my students really do know what's going on with it. So let's have a look at this recursive function. I know already you're looking at it. It looks simple at first glance, but then you notice, hang on a minute, it's calling itself from within itself. And this is one of the big jokes of factorials, of recursive functions, is that they are from within. So they call themselves from inside themselves. You try recursion, you put that into Google and it'll say, see recursion. And so here we are. We have return factorial, and you can see straight away we have this recursive call. So it's calling itself from inside itself. Very important, and this is the bit that causes quite a lot of confusion. And so the first time it goes through, it goes factorial 5. Okay, hasn't got the answer there, so it moves on to factorial 4, 3, 2, and then it hits what we call the base case. Now the base case is the end of this. So for a good recursive function, you have to have some kind of base case. Okay, then it starts returning backwards. So then we get the first return, which is 1. It then goes back and says, right, okay, I've done that. So what do I do? 2, 6, 24. And finally, it will give the user back the 120 answer. So here is your example code. Take a look at it if you like. Of course, there is a link to it in the description below. So, a lot of people, unless they're doing an exam, they probably won't use recursion very much, with a couple of really important exceptions. The number one exception is if you're doing it for science or you're doing it for mathematics, you probably will use it for mathematical formulae. And it's used a lot in Python for science for this reason, because it's very similar to the way that the maths recursive problems are solved. Sometimes it's also used for flattening lists and going through directory structures. There are arguments to and forth about iterative. And I will tell you that Python, generally speaking, favors the iterative approach. So this is really mostly used for math formulas and things like that. But let's have a look at a couple of these lists. So here is one example to flatten a list. We have our general case, we have our recursive calls, and we have our base case. Okay, so when it gets to the end of it, it just returns the list and starts the process. Another one, how do you know this is recursive? Well, literally, because in this one, we're using a library and it says recursive equals true. But I thought it's really fun. do have a play with this, because it does generate a lovely list and huge amounts of potential for searching through files, looking for different things. And it was originally designed for Linux and for servers, but a lot of useful functionality can be generated from this. So that's what we've done today. That's an introduction to recursive functions, and I hope it makes things a little bit clearer for you. If you're enjoying the channel, please do leave a comment, leave a like. I have no idea how much you're enjoying these things, if these things are useful, if you don't do that. But please, I'd love to subscribe. I'm really aiming to get for that 1,000 so that I can get the special YouTube privileges of having 1,000 subscribers. Take care. All the best. See you next time.